All right, now for question 1. Web App Security Limited has web servers that frequently connect to a shared Amazon RDS MySQL multi-AZDB instance. They need a secure connection method and frequent rotation of database user credentials. What is the recommended solution? Select one answer. Review the answer choices on screen. The correct answer is option C. Secrets Manager was built for exactly this use case. AWS Secrets Manager is specifically designed for managing secrets like database credentials. It allows applications, via IAM rules, to retrieve credentials at runtime, avoiding hard coding. Crucially, Secrets Manager supports automatic rotation of credentials for services like RDS MySQL, fulfilling the frequent rotation requirement securely and with minimal operational burden. What's up, everyone? Another batch from Stack Lessons. 10 questions on credential security, traffic decoupling, and WAF and VPC access controls. Format is the same: question, countdown, reveal, explanation. 6 seconds is the timer. Strap in. Keep score as you go. I will ask for your total at the end. All right, question 2. Coming up, Audit Log Corp hosts its multi-tier applications on AWS. For compliance, governance, auditing, and security purposes, they must monitor configuration changes on their AWS resources and maintain a history of API calls made to these resources. What combination of AWS services should be used? Select one answer. Review the answer choices on screen. The correct answer is option B. CloudWatch logs events but not configuration state. AWS Config is specifically designed to track changes to resource configurations over time, providing a history and enabling compliance checks. AWS CloudTrail is a service that records API calls made to AWS resources, capturing details like who made the call, when, from where, and what actions were taken. Together, these services provide comprehensive tracking for configuration changes and API activity. Okay, question 3. Separate context from noise. Real-Time DB Write Corp has an API receiving real-time data from monitoring devices, storing it in RDS. Data volume fluctuates. During heavy traffic, the API times out as the database can't process writes fast enough. A solutions architect must minimize database connections and prevent data loss during heavy traffic. What is the best approach? Select one answer. Review the answer choices on screen. The correct answer is option C. SQS acts as the shock absorber between API and RDS. Decoupling the API from the database using an Amazon SQS queue provides a buffer for incoming data. The API can quickly write data to SQS. An AWS Lambda function, or a fleet of EC2 workers, can then consume messages from the SQS queue at a rate the database can handle. This prevents the API from timing out due to database overload and ensures data is not lost, as SQS will retain messages until successfully processed. Okay, here comes question 4. Stateless App is tasked with making a stateless 2-tier application highly available. The application currently uses Amazon EC2 instances in a single availability zone and an Amazon RDS multi-AZDB instance. What architectural modification should a solutions architect implement to ensure the application tier itself is also highly available? Select one answer. Review the answer choices on screen. The correct answer is option D. Cross-region failover is overkill when AZ has already solved this. To make the stateless application tier highly available, it should be deployed across multiple availability zones, as is. This can be achieved by placing the EC2 instances into an auto scaling group configured to launch instances in 2 or more AZs. An application load balancer, ALB, should also be configured to span these same AZs and distribute incoming traffic across the healthy EC2 instances in the auto scaling group. This setup ensures that if one AZ becomes unavailable, the application can continue to serve traffic from the instances in the other AZs as. Next up, question 5. Keep the constraints in view. Doc Report DB Inc. hosts a 3-tier web application with a PostgreSQL database storing document metadata. Key terms in this metadata are searched monthly to retrieve documents stored in S3 for a report. Documents are written once but updated frequently. The reporting process, using relational queries, takes hours and must not block document modifications or additions. A solution is needed to speed up reporting with minimal application code changes. What's best? Select one answer. Review the answer choices on screen. The correct answer is option B. Aurora replicas isolate heavy reads without any schema changes. Amazon Aurora PostgreSQL replicas, Aurora replicas, which can offload read-heavy workloads from the primary writer instance. By directing the long-running reporting queries to an Aurora replica, the primary instance remains available and performant for ongoing document modifications and additions. This significantly speeds up the reporting process without impacting the transactional workload and generally requires minimal changes to the application code, just pointing report queries to the replica endpoint. First 5 covered credential rotation, config plus CloudTrail pairing, SQS write buffering, multi-AZ spreading, and Aurora read isolation, the core decoupling toolkit. Now, question 6. Underline the key phrase mentally. Order Workflows serverless needs to build a distributed application for order processing, involving several serverless functions and AWS services. The workflow requires manual approval steps. A solutions architect needs an architecture that combines multiple Lambda functions into responsive serverless applications and orchestrates data services running on EC2, containers, or on-premises. What provides this with least operational overhead? Select one answer. Review the answer choices on screen. The correct answer is option D. Manual approval steps are step functions native territory. AWS Step Functions is a serverless orchestration service that lets you coordinate multiple AWS services into serverless workflows. It excels at building distributed applications, automating processes, and orchestrating microservices. Step functions can directly invoke Lambda functions, integrate with other AWS services, including EC2 and ECS via specific integrations, and importantly, supports human approval steps, e.g., using callback patterns or integrations with services like Amazon SQS for notifications. This provides a visual workflow, error handling, and state management with minimal operational overhead for complex, multi-step processes. Next up, question 7. The trap is in the setup. Private S3 transfer needs to move data from an Amazon EC2 instance to an Amazon S3 bucket. A strict company policy mandates that no API calls or data related to this transfer should traverse public internet routes. Furthermore, access control must ensure that only this specific EC2 instance has the permission to upload data to the designated S3 bucket. Which AWS networking and security configuration will satisfy these stringent requirements? Select one answer. Review the answer choices on screen. The correct answer is option D. S3 has 2 endpoint types. The word interface matters here. An interface VPC endpoint for Amazon S3, which is powered by AWS Private Link, allows private connectivity from your VPC directly to S3 APIs without requiring traffic to traverse the public internet. This directly meets the requirement for no public internet routes. To ensure that only the specific EC2 instance can upload data, you should use an IAM role attached to the EC2 instance. The S3 bucket policy can then be configured with a condition that allows actions like S3 put objects only if the request comes from this specific IAM role, or via the specific VPC endpoint if you want, to further restrict by network path. This combination provides both private network connectivity and fine-grained, identity-based access control. This one tests two ideas at once: private networking and access control. Let's break it down. Imagine your EC2 needs to push 50,000 log files a day to S3. Your security team says, no internet, period. Here's how to think through it. First, does the traffic leave AWS's private network? A NAT gateway routes through public IP space. That's internet. A VPC endpoint keeps the path inside AWS. Second, who controls upload access? S3 access control lists tied to an IP address are brittle. Your EC2's IAM role is its actual identity. Third, can you satisfy both at once? Yes. An interface VPC endpoint routes traffic privately. Then a bucket policy locked to that IAM role controls who can upload. That's the combination. That's answer D. Now, question 8. Prioritize the stated requirement. Social media image uploads wants to build a feature for its website that allows users to upload photos. The company anticipates that demand for this feature will experience significant and unpredictable increases, especially during large public events. They need to ensure that the website can reliably handle the upload traffic from a potentially massive number of users concurrently. Which architectural solution meets these requirements with the most scalability and efficiency for handling the uploads? Select one answer. Review the answer choices on screen. The correct answer is option C. Clients upload directly to S3, bypassing your application servers entirely. Amazon S3 presigned URLs provide a secure and highly scalable method for allowing clients, such as a user's browser or mobile application, to directly upload files to an Amazon S3 bucket without the files having to pass through your application servers. The application backend first authenticates the user and then generates a short-lived, secure presigned URL that grants temporary put object permission for a specific object key in S3. The client then uses this URL to upload the file directly to S3. This offloads the data transfer from your application servers, allowing S3 to handle the scalability and throughput of the uploads directly. This is extremely efficient for handling large numbers of concurrent uploads. Now, question 9. Small wording, big difference. Word cost tracking wants to enhance its AWS cost management. The company uses AWS organizations, and resources are tagged by account. The accounting team needs to determine spending on Amazon EC2 consumption specifically. A critical requirement is to attribute these EC2 costs to the respective departments, regardless of which AWS account incurred the cost. The accounting team has access to AWS Cost Explorer for all AWS accounts within the organization and needs to access all relevant reports from Cost Explorer. Which approach is the most operationally efficient way to generate these departmental EC2 cost reports? Select one answer. Review the answer choices on screen. The correct answer is option D. Tag activation only happens from the management account. AWS Cost Explorer, when accessed from the AWS organization's management account, provides a consolidated view of costs across all member accounts. By activating user-defined cost allocation tags, like a department tag that is applied to EC2 instances, these tags become available as filters and grouping dimensions in Cost Explorer. The accounting team can then create a single report in Cost Explorer, filter by the Amazon EC2 service, and group the cost by the department tag. This provides a clear breakdown of EC2 spending by department across the entire organization with minimal operational effort, as Cost Explorer handles the aggregation and presentation. Let's slow down here. This one tests whether you know how Cost Explorer handles org-wide tagging. Imagine your company runs 15 AWS accounts. Dev, staging, prod, one per team. Finance asks, how much did the marketing department spend on EC2 last quarter? Without the right setup, you're downloading 15 separate billing exports and stitching them together in Excel. Here's the shortcut. Go to your organization's management account. In the billing console, activate a tag key called Department. Once active, Cost Explorer can see that tag across every member account automatically. Now create one report, filter to Amazon EC2, group by department, and you get a clean breakdown in minutes. The trap is thinking you need to log into each account separately. You don't. One tag activation, one report. That's why D wins. Let us keep moving. Question 10. Several choices sound plausible. Global App Security needs to protect its web application, which serves clients deployed in over 20,000 retail storefront locations worldwide. The application consists of backend web services exposed over HTTPS on port 443, hosted on Amazon EC2 instances behind an application load balancer, ALB. These retail locations communicate with the web application over the public internet. The company allows each retail location to register the static public IP address that their location has been allocated by its local internet service provider, EISP. The company's security team now recommends enhancing the security of the application endpoint by restricting access to allow connections only from these pre-registered IP addresses of the retail locations. What should a solutions architect implement to meet this specific IP-based access restriction requirement? Select one answer. Review the answer choices on screen. The correct answer is option C. Security groups hit their ceiling long before 20,000 source IPs. AWS WAF, Web Application Firewall, is designed to protect web applications from common web exploits and can be used to filter traffic based on various conditions, including source IP addresses. By creating an IP set in AWS WAF that contains the list of all registered trusted IP addresses from the retail storefront locations, you can then create a rule in a web ACL associated with the application load balancer that allows requests only if their source IP address is present in this IP set. All other requests from non-listed IP addresses would be blocked. This provides a scalable and manageable way to enforce IP-based access restrictions at the edge before traffic reaches the back-end application servers. This one trips people up. Security groups feel right, but they're working in the wrong place. Imagine you're a bouncer checking IDs at the front door, but someone put you in the back room, past the bar. That's option A. Security groups on EC2 only see the ALB's private IP, not the original retail store IP. By the time the request reaches EC2, the source is already rewritten. Every request looks like it came from the same person, the load balancer. Makos have a different trap. They max out at 40 inbound rules. You have 20,000 stores. AWS WAF sits right at the ALB's front door. It sees the real source IP before anything touches it. Each WAF IP set holds up to 10,000 addresses. 2 sets cover all 20,000. That's why WAF wins. It's the only tool here built for this job. 3 takeaways from this session. First, Secrets Manager natively rotates RDS credentials, never hardcode or pass access keys to application code. Second, an SQS queue between your API and RDS absorbs write spikes without dropping a single record. Third, security groups hit their per-group ceiling fast. AWS WAF IP sets are built for thousands of source IPs. Buffer before you break, enforce access at the right layer, and not just the nearest one, and let org-wide costs collapse into a single query. Those 3 instincts thread through this set, and they keep showing up on the exam. One more thing before you go. If these sets are useful, hit subscribe. It keeps them free and reaches more people like you. Drop your score below and flag any question worth a deeper look. Want a different exam covered next? Just name it. And if the speed or style could improve, tell me. That shapes the next batch.